Hey everyone. So for this presentation class, we're going to talk about the measures of variations and the coefficient of variations. So we're not going to solve using the formula for the entire presentations here class, but of course, I'm just going to give you an example on how we are going to solve using a formula, but we focus here on the applications of the measures of variations with that of the coefficient of variations. So say for example, class, if we have here the grades of Bogart and Berta, so if you're going to look at the grades of the different subjects, so there are 7 subjects, and you see that there are really differences in their grades. And if you're going to add the total grades, okay, of these two students, then it so happens class that they are equals. So if you're going to take the mean grade for these two students, Bogart and Berta, by dividing 609 by 7, because there are 7 subjects, then it will give us a result of 87. Because their mean grades class are the same, however, looking into their individual grades, they are really different. So if you're going to base their grades based on the mean, you would say that they are performing equally. But looking into the individual grades class, it's not. So this is where the mean as a value class, as a measures of center, failed us now to give a comparison which one is better than the other using the mean. If you're going to use the median, so median class will also give us the same result, because if you're going to rearrange these grades from highest to lowest or vice versa, then the middlemost value will give us 87 as well. So meaning there are 3 grades of Bogart and Berta that are above 87, and another 3 grades of both Bogart and Berta that is below 87. So based on the mean and the median class, so we cannot really say who performs better in terms of their grades. So is it Berta or is it Bogart? So this is where the other measures now comes in class, because when we base it from the mean and median, both Bogart and Berta perform equally. But as I said, because we are going to look into each scores individually, and we are going to find out, okay, how close or how far each individual grades are from the center, and that is the concern class of what we call the measures of variations. So a measure of variation class, this is actually ways to describe the distribution or any dispersion of data. How far apart are the data points, referring now to the individual grades here, are from one another. So you can draw many conclusions by using measures of variations, like which of these two is said to be a high variability or which one has a low variability. Okay, so that's the use class of a measures of this version. So I'm just introducing to you class the formula for the variance and the standard deviations, just to have to give you an idea, but our purpose here class is not really into solving the standard deviations, but simply I'm just going to give you an idea on how we are going to solve the standard deviation. So the relationships between these two classes, that the variance is the square of the standard deviation, and the standard deviation is the square root of your variance. So sometimes class, if you are given the variance, you can always solve for the standard deviations by taking its square root. Or sometimes you are given the standard deviations, and if you are asked what is the variance, all you have to do class is you're going to square your standard deviation. Okay, now if we go back to the grades of Bogart and Berta, so we already have the total of their grades, which is equivalent to 609. But if you're going to square their grades class, so squaring their grades, then you add, then this is where you see now the differences. For Bogart, the sum of the squared of his grades is 53,031, while the sum of the squared of Berta's grades, represented by your x squared, is 53,021. So this is already giving us that Berta's squared grades, when we add, is lower than that of Bogart. So if we're going now to apply the formula to find the variance and the standard deviation, so these are the things that we need, class, in a data set. We need the sum of the scores or the sum of the grades in this particular problem, then the sum of the squared grades. So we need to square it first, then we add. And of course, the third one is how many grades are there. So each Bogart and Berta have 7 grades. Okay, they have 7 grades from 7 different uh, classes or subjects. So using the formula, class, I'm just using the color coding here that we are going to plug in our formula. So this is the formula for the variance, class. So just to give you an idea on how we usually compute for this one. So here we have the total of the squared grades of Bogart multiplied to 7 because there are 7 grades, minus you square now the total of Bogart's total grades, which is 609. Then 7 here is the number of subjects times n minus 1. So you have to subtract 1 from 7. Likewise, for Berta, it's similar. There are also 7 different subjects, thus giving us 7 grades as well. This is the sum of the squared of the grades of Berta minus the total sum of the grades of Berta squared, then divided by 7 times 6 as well. So if you're going to simplify both of these, then what we have is the variance. We notice, class, that the variance grades of Bogart is greater compared to Berta. So 8 is greater than 6.33. So this gives us an idea, class, that the grades of Berta are more closer to one another compared to Bogart, because according to the definition, class, of the measures of dispersion, okay, so how far or how near or how close are the individual scores from one another. So the lower the value, okay, closer to 0, it means that the scores are closer to one another. The greater the value or the farther, okay, of your standard deviations or variance means that the scores or the grades are far from one another. Okay, so if you take the square root of these values, class, the result is the standard deviation. So here you can see clearly, class, that Bogart's standard deviations of his grades is 2.83, while Berta's standard deviations of her grades is 2.52, which is lower compared to Bogart. Now, we can see here that there is already the difference in terms of their measures of variations. So how are we going to interpret this, class? Going back again to this table, the mean are the same, the median are the same, but in this case, their standard deviations now are different. So this is where we can now see clearly that because Berta has a lower standard deviations of 2.52 compared to Bogart's of 2.83, therefore Berta performs consistently compared to Bogart. Okay, so the grades of Berta are more closer from one another compared to the grades of Bogart. Thus, in terms of consistency, class, Berta's grades are more consistent compared to Bogart. Okay, so this is where now the coefficient of variations comes in. Okay, so the coefficient of variation, class, is simply the ratio of the standard deviation to the mean, and it shows the extent of variability in relation to the mean of the populations, or in our sample case. So data with lesser coefficient of variations in terms of percentage is more consistent or stable than the other data. So the lower the coefficient of variation, the lesser the dispersion. The higher the coefficient of variations, the greater the dispersion, provided, class, that they have the same mean values. So we can convert both Bogart's and Berta's grades into coefficient of variations, and we want to find out in terms of percentage, okay, how varied are the grades of Bogart's or Berta's. Now we can see here clearly, class, that Bogart's grades is 3.25%, okay, varied, okay, while Berta's grades is only 2.90% varied, okay, from the mean. So the lesser the coefficient of variations, the more stable or the more consistent. So we can now answer or say now that Berta's grades are less varied relative to the mean grade compared to Bogart's grade, which is about 3.25%. So we can now say that, okay, we can go back here, class, that really Berta's grades are more consistent than Bogart. So another example, class, is this one. You found out that in Jolly Wasp, the mean price of any burger is about 155 pesos with a standard deviation of 15 pesos, while in McDonald's, the mean price of any burger is about 160 pesos with a standard deviation of 15.5 pesos. Now, in which fast food are the price of burgers less varied? Now, say for example, you only have uh, a limited budget, so you want to find out which of these two, okay, like say for example fast foods, okay, can have variations of the prices of burgers which are very very close to one another. So just because, class, we have the 15 pesos in Jolly Wasp is lower than 15.5, so does not mean that this is now has a lesser variation, because we also have to look the mean value. Okay, so it also depends on the mean value. So in this case, class, we are going to use the coefficient of variations, and we just divide the standard deviations by its mean value times 100%, and this will give us the percentage. So we can see here is very very close, class, that 9.677% in Jolly Wasp is the coefficient of variations, while in McDonald, the coefficient of variations is about 9.688%. So very, very close. But still, we could say now that it is in Jolly Wasp has the least varied burger. So if you only have, siguro, let's say, what about if you only bring with you a money that is only a maximum of 160, perhaps, okay, then so that you can also have more choices now to buy the burgers, then definitely you go to Jolly Wasp because you have more, okay, burgers to choose from with their prices are very very close to 155 compared to McDowell. Okay, so that's an example also, class, of how the coefficient of variations works. Now, another example of the use of the coefficient of variation, class, is the following data are the mean scores and standard deviations of three different classes or sections about their final exams in mathematics. So in which sections are the individual students have the greatest variations of scores? In which sections are the individual students have the least variations of scores? Although, class, we are given in terms of mean and standard deviations, but because the use of the coefficient of variations, we can now visualize which of these three sections will give us, okay, an idea that which among these, okay, sections where the students scores are very close to one another. Okay, so again, the lower the value or the lesser the value of the coefficient of variations, the more consistent or the more stable the data is. So we need to convert these values here into the coefficient of variations using the formula. Again, you divide the standard deviations by mean times 100%. So among the three sections, if you're going to convert now their grades, okay, and find out the individual grades, so which gives us now more varied or least varied in terms of their individual scores based from the mean and standard deviation. So we can see here clearly, class, that the highest percentage is 4.67 and the lowest percentage is 3.33. So indicating, class, that the most varied individual scores are found in section B, while the least varied individual scores are found in section C. So in terms of consistency, class, you could say that in section C, the students there are more consistent in terms of their individual scores compared to the other sections, while in section B, so the grades or the scores of the students there in section B are more varied compared to the other two sections. Okay, so that's the use class of the coefficient of variations.